Hey guys, this is lesson 10 in the real numbers course. In our last lesson, we introduced the notion of equivalent fractions. And we saw that those are fractions that are really equal, they just look different. Okay, that's really important. Fractions can look different, but still be equal to one another. We saw that, for example, 4/8 is really equivalent to 1/2. They're equal to each other, but just look different. And we saw it in a variety of ways. We used our number bars. So here's 4/8. 8 equal pieces, keep 4 of them. But if we blurred some of those lines out, we noticed, yeah, we're really looking at 1/2. We also saw the arithmetic involved in showing that one fraction equals another. And it came down to factoring the top and factoring the bottom and noticing when we split those two fractions up, 4/4 is really 1. And 1 times 1/2 is 1/2. And that's how we said in our last lesson that we would simplify any fraction. To simplify a fraction, you factor out a 1. So we've got a pretty good handle on simplifying, and you guys have practiced that up at this point, I hope. So we're good to go. With simplifying, you factor out a 1. But it turns out sometimes you might want to take a fraction and complicate it a little bit. You might need to put on a different outfit for some particular occasion, just like people, right? So if you take a fraction and you multiply in a 1, you put on another outfit for some event, then we call that anti-simplifying. And it works exactly the opposite of simplifying, hence the name. Okay, so it turns out if you want to anti-simplify a fraction, you multiply in a 1. Exactly the opposite of simplifying, where we factor out a 1. To anti-simplify, you multiply in a 1. You multiply by 1. So let me give you an example. We'll start with the familiar guy. Let's take 1/2 and let's anti-simplify it or convert it into eighths. So we want to put its eighths outfit on. All right, where it's going to some event and it needs its eighth outfit on. All right, well, what we need to figure out is what form of 1 are we going to use to convert 1/2 into eighths. We have to keep it the same number. We don't want to change the value, just the look. And we do that by 1. Okay, we can't cheat and multiply by some other number. So let's multiply by 1. And if you think back to how we simplified this in our last lesson, or just a few slides ago, it does seem like 4/4 would be a good one to try, right? So we see 2 times 4 gives us the 8 in the denominator, and 1 times 4 gives us the 4 in the numerator. So there we go. To anti-simplify a fraction, you multiply by 1. All right, let's do some examples here. Let's say you wanted to convert 2/3 into 20/1. So we want to take a fraction in its thirds outfit and convert it into 21st. So we're going to anti-simplify here. All right, well, we've got 2/3. We want to write it as a fraction in 21st. So again, it comes down to what is that 1? Well, I'll tell you what, why don't we try the guy that worked a little while ago? Let's try 4/4. If we try 4/4 in there, does that work? Let's see, we got the 3 times the 4 equals 12, not 21. All right, so no, that's no good. It's not 4. How about 5? Excuse me, 5/5, right? Can't cheat. Got to multiply by 1. So there's a 1. There's a version of 1. See, 3 times 5 is, no, it's not 21. That's only 15, isn't it? Okay, so that's not the form of 1 we need either. You guys seeing what we might need here? Yeah, okay, 3 times what will give me 21? Maybe 7 for that denominator, right? Okay, well, if that's true, then it's got to be 7/7 that we multiply. Let's give it a shot. 7/7. So in the denominator, 3 times 7 is 21, good. And 2 times 7 is 14. There we go. Looking good. So 2/3 is exactly the same number as 14/21. They just look different. And we converted or anti-simplified by multiplying by 1. All right? Very nice. Let's do another one. What if we wanted to convert 3/4 to 20ths? All right, well, same deal. We want to take 3/4. We want to convert it into an equal fraction that has a denominator of 20. So again, it comes down to what's the 1? What's the form of 1 that we need here? So at this point, you want to sort of be able to see that without trial and error like we did the last time. Let's use what we came to. 4 times something has to give us 20 in that denominator. So it looks like 5, huh? So don't cheat. We need to convert by multiplying by 1. That's what keeps the number the same. That's the crucial thing. So let's try 5/5. 5/5. So 4 times 5 is 20 in the denominator. That's good. And 3 times 5 is 15. There we go. 3/4 is equivalent to 15/20. They're equal. They just look different. And we converted, keeping them the same by multiplying by 1. All right. Excellent. Sometimes you might need to take 2 fractions with different denominators and convert them into equivalent fractions so they have the same denominator. We call it a common denominator. That turns out to be important in lots of situations. So we'll see that later. But for right now, let's just talk about the converting. So we want to take 3/5 and 4/7 and we want to convert them into equivalent versions of themselves with the same denominator. So what can we turn both of those fractions into, 5ths and 7ths? What can we convert 5ths and 7ths into? It turns out that's very easy to figure out. You just take the 2 denominators and multiply them together. That's it. Okay, so 5ths and 7ths, we can convert those into 35ths. Okay, 5 times 7. So now it just comes down to, let's convert by finding the ones that will convert those fractions into 35ths. There'll be different ones for sure. So 3/5 into 35ths, we're going to need, looks like 7/7. 7/7. Let's put that in there. So 5 times 7 is 35. 3 times 7 is 21. All right, so 3/5 is really the same number as 21/35. It's just got its 35ths outfit on. 4/7 times, let's see, looks like we need 7 times 5. 5/5. 5/5 there. In this case, that's the one. So 7 times 5 is 35 and 4 times 5 is 20. 35ths. All right, there we go. So the same guys, they're just dressed up in the same outfits. They both are in their 35ths outfit. All right, here's one more. Let's say you want to convert 7/20 to a percent. Well, we know what that means. We're going to take 7/20. We're going to multiply it by 1 to get a denominator of 100 and an equivalent form of itself in hundredths. So let's see, what is that 1? I think you can probably see that pretty easily. 20 times 5 will get us 100. So the form of 1 is 5/5. Nothing to it. Nothing to it. 20 times 5 is 100, of course, and 7 times 5 is 35. So 7/20 is 35/100, or if you wanted to write it with the percent symbol, it's 35%. Okay? Now, tell you what, talking about percents like that brings up something important. There are some famous percents and fractions that come up all the time. All right, so you want to recognize them in either one of their forms. So let's convert the following important fractions into their percent versions. All right, so 1/4, 1/2, and 3/4. Those are pretty famous benchmarks we've seen, famous fractions. So let's convert those into hundredths. So what we need to do is, same thing as all the others, let's find the appropriate ones. All right, so 1/4 times, it looks like 25 25ths is the one we need there. 4 times 5 is 100. 1 times 25 is 25 hundredths. So 1/4 is 25%. 1/2, the form of 1 we're going to need there. Can you guys see it? Yeah, say it. Say it louder. No, come on. Don't be shy. No, yeah. 50/50 is excellent. Excellent job. Very nice. 50/50. That's the 1. 2 times 50 is 100. 1 times 50 is 50. Good. And then 3/4. Let's find that appropriate 1 version of 1. Oh, it's the same one as the 1/4, isn't it? So 25/25. So 4 times 5 is still 100. 3 times 25 is 75. We got it. There they are. 3/4 is 75%. There they are. You just want to have those automatically without converting every time. 1/4 is 25%. 1/2 is 50%. We sort of talked about that before. And 3/4 is 75%. Looking okay? So the big deal here is to simplify a fraction, you factor out a 1. And to anti-simplify a fraction, you multiply in a 1. All right? That's all I've got to talk about today. Excellent job. Have a great day, and I'll see you in our next lesson.